to another video, and finally, we've got it.
Hi everyone, your creative educator here, and welcome to Sparks to Flames Education, where you get great science, math, and reading content, and really fun and creative ways of inspiring learning. Remember to subscribe, hit the notification so that you can see our new videos on Mondays. Like and share, and yes, subscribe now. Thank you.
So in our previous fading color videos, we've been trying to investigate why the red ball faded in color while it was outside in the sun. We came up with a whole bunch of things. First, we realized that the sun gives off lots of energy, light energy, heat energy, etc. We realized that you could take the light energy from the sun and break it down and you get the colors of the rainbow. We realized that if you put something in the sunlight, the color can determine how much heat it absorbs. Because when we look at the ice, when we put it in the sunlight, it melted. However, it melted differently in the different color containers. So we realized that the color of the container has something to do with how much heat is absorbed. Then we said, how could this be? Either it's the color or it's the material. We investigated the material and we realized that different materials also fade in the sunlight. So it's not because the ball is made of a certain material. And when we look at the colors, we notice that the red colors really do fade. So we started to think maybe it has something to do with the color itself. So we investigated pigments. Pigments are natural color-giving chemicals that we find in nature. So we looked at pigments from berries, pigments from turmeric, and we had a fun painting activity with that. But then we noticed that with pigments are made up of chemicals, and these chemicals are made up of atoms, and atoms join together or form bonds. But these bonds can be broken, and when the bonds from the atoms break, the chemical that they make up also changes. So now we're thinking, ding, that might be what is happening to the color. The chemical, the pigment that makes up the red color might be changing because the bonds that hold the atoms together are changing. So now what causes the bonds to change? Energy. If the chemicals absorb energy or if they lose energy, then the bonds will change. And if the bonds change, the chemical changes and the color that the pigment gives off changes. So now we're finally putting it all together. Why does the red one fade faster than all the others? So we know that it's absorbing energy, the bonds are changing, the colors are changing, but why does the red one fade faster? So that's what we investigated today. And what we did is we took a look at the different colors and how they're related to energy. So in this video, we have a radiometer. A radiometer is a structure that absorbs sunlight and then it moves based on the amount of energy it's getting from the sunlight. But then we took a look at the different colors and we tried to use the same idea. Will the radiometer work if the light is a different color, if it's not the full sunlight? So we tried these different colors, and as you can see, it moves differently with different colors. For some colors it moves faster, for some colors it moves slower. So what does that mean? It means that those colors might be giving off more energy or less energy. So that means that some colors give off more, some colors of light, not regular old pigment, but some colors of light, because there's a difference. Pigments give off colors that they reflect, but light is the natural energy. So some colors give off different energy. Now talking about reflecting.
Okay, everybody, check this out. So I'm going to use this demonstration. Children, do not do this at home, only the grown-ups. Hi everybody, I'm going to use this flame setup to kind of explain how color and light and energy works. So we see this candle and it's burning a yellow flame, and then we see this flame from the lighter and we notice that a part of it is blue, and that's where the gas is coming out of the lighter. So that's where the energy for the flame is. And as we move towards the tip, we see that that is more yellow. That's where the oxygen is. So when the flame is burning, the blue part is where there's lots of energy, gas coming out, and the yellow part is where it's interacting with oxygen. So
Alright everybody, we're out in the sun, but it's for a good reason. Of course, we absorb sunlight, we use it to make vitamin D and get us all charged up and a whole bunch of other things. But today what I'm showing you is how objects interact with sunlight. So we have 4 different objects. We have this wonderful science kit box, get your science kits. We have the CD, we have a prism, and we have a mirror. So how do they reflect or interact with light? So the mirror definitely reflects the light. So you see the reflected light right there. The prism changes the direction of the light. You see the light going in 2 different directions here. The CD breaks down the light so that you see the different colors that make up the light. So you see all these rainbow colors right there. There you go. So we have reflecting, changing the direction, breaking down the light. And then the last thing is what this box is doing. Pretty much nothing. The box simply absorbs the light. So these are a couple of things that can happen with light when objects interact with light. So reflect it, changes direction, break it down, or absorb it. Reflecting is. An object like a mirror will reflect the entire light spectrum. It will reflect all the colors that make up the light. But some objects only reflect some colors and will absorb all the other colors. So an object that is, say, red is going to absorb all the other colors. It only reflects red, so we see red. An object that is, say, blue will absorb all the other colors but will reflect blue. And blue is more of a high energy color. Just like you saw with the flames, with the light. The blue color is when you have lots of energy. So if something is reflecting blue, it means it's absorbing all the other colors, but it's giving off that blue energy, blue light. So if something is red, it's absorbing all the high energy colors, but it's giving off the lower energy color, which is red. And because it's absorbing all the high energy colors, all that high energy will cause those pigments to change. All right, everybody. Thank you. Join us next week, Monday, for another video. Please, please, please remember to like, share, and subscribe. Peace out.